Good morning, students. Last session we had seen what is the average rate and the instantaneous rate, and graphically how can we determine the two. Now in this session we are doing the factors influencing rate of reaction. Now when a chemical reaction is carried out, the rate of reaction depends upon experimental conditions. Experimental conditions, that is the concentration of the reactants used, however, if the gases are involved, then pressures can be taken instead of concentration. Concentration of the reactants used or the pressure of gaseous reactants. Then it also depends upon temperature and the catalyst used. All these factors we are going to study in detail, but first factor we are starting with is concentration of reactants. The first factor that we are studying that influences the rate of reaction is concentration of reactants. We know that rate of reaction depends upon the concentration of one or more reactants involved in a chemical reaction. The representation of rate of reaction in terms of concentration of reactants is called the rate law. Again, I am repeating, the representation of rate of reaction in terms of concentration of reactants. I'm only saying reactants, no products. In terms of reactants is called rate law or rate expression, or sometimes also as rate equation. The representation of rate of reaction in terms of concentration of reactants is called rate law or rate expression. Let us see an example and then we will define what is actually a rate law or the rate law expression. Let us see. Let us consider the hypothetical reaction that we have been using again and again in this chapter. So let us consider the hypothetical reaction AA plus BB gives CDD. You know, capital A, capital B are the reactant, capital C, capital D are the products, and small a, b, c, d are the stoichiometric coefficients. Now, for this reaction, it has been found, we have to write how the rate depends upon the concentration of reactants. It has been found that rate of reaction is directly proportional to the concentration product of concentration of reactants. We are multiplying the concentration of reactants raised to certain powers, and these powers may or may not be equal to the stoichiometric coefficients. It is not necessary that x is equal to a. It may or it may not be. It is not necessary y is equal to b. It may or it may not be. X and y, that means rate, depends upon which power of the concentration of reactants is determined experimentally. we cannot determine the rate expression theoretically from a balanced chemical equation. This has been determined experimentally. So x and y may or may not be equal to the stoichiometric coefficients A and B. Now when I remove the proportionality sign, I will put a constant, so rate is equal to K, A to the power X, B to the power Y. K is called as the rate constant and X and this expression is called as the rate law or the rate expression or maybe rate law expression. K, the proportionality constant, is called rate constant and this expression is the rate law. So this is your expression of rate law. Now how we can define the rate law? You can write the definition of the rate law. Rate law is an expression in which the rate of reaction is given in terms of molar concentration of reactants raised to certain powers which may or may not be equal to the stoichiometric coefficients shown in the balanced equation. Shown in the balanced chemical equation. Again, I am repeating. Rate law is an expression in which the rate of reaction is expressed in terms of molar concentration of reactants raised to certain powers which may or may not be equal to the stoichiometric coefficients shown in a balanced chemical equation. Now let us understand the meaning of this. Again, you can see the stoichiometric coefficients are A and B. Rate is expressed in the terms of concentration of reactants. They are raised to some powers X and Y which may or may not be equal to A and B. I take up an example of equation. Few equations in fact. I take up, this is a reaction, NO2 reacts with fluorine and the product formed is NO2F. The stoichiometric coefficients are 2 and here nothing is written, that means stoichiometric coefficient is 1. The rate of reaction has been found to be K NO2 F2. So you can see that NO2, what is the power in the rate law expression? The power is 1. Here it is 2. So they are not equal. But here it is 1, here also it is 1. It is equal. How we have determined what it will be? Why it is 1 here? Why 1? This has been determined experimentally. I cannot see this equation and write this rate law expression. You have to understand, I have learned this expression, so I have written. I can only determine this expression experimentally. I cannot find it theoretically. Let us take one more example. This is the reaction. Rate is equal to K CHCl3 Cl2 to the power half. Now you can see here the stoichiometric coefficient is 1, but here it is 1 by 2. And by seeing this equation, I cannot write this expression. Rate law, you have to remember, rate law can only be determined experimentally. I cannot determine it theoretically from this equation. From this equation, I will never come to know कि Cl2 is to the power half or what. I take third example. This is the reaction. 2NO plus O2 gives 2NO2. The rate of reaction is equal to K NO to the power 2, O2 to the power 1. You can see, in this case, stoichiometric coefficients are exactly equal. 2 and 2, 1 and 1. But we have not written it according to the balanced chemical equation. It has been determined experimentally. The rate law expression or rate law can only be determined experimentally. We cannot find it from a balanced chemical equation. So this we have done with your rate law. Thank you.